Today we'll talk about major takeaways from the organic chemistry acids bases unit. The first one is comparing which acid is stronger. The second one is comparing which would be the favorable reaction direction or which would not be. So in the first examples, the questions asks, rank the following bold-phased hydrogens from most acidic to least acidic. The best thing to do is to memorize your pKa's. So here, carboxylic acid, pKa 3 to 5. Here, alkene, so 44. The third one, it looks like an alcohol, but because it is protonated, it has a pKa of -2. Alkyne looks like an alcohol, but not really, because it's an alcohol that is attached to an benzene, so it's going to be a phenol with a pKa of 10 instead of 16 alcohol. So most acidic is going to be the one with the lowest pKa. Let's try one more. Carboxylic acid. Here, it looks like an amine, right? Because there is an NH, but amines have a lone pair on H. But because here there's a positive charge on the H, it's a protonated amine, which has a pKa of only 10. This is alkane, because when you see a single bond, nothing special, you know it's an alkane 55. Here it looks like an alcohol with a pKa of 16, but it's protonated, so pKa of -2. Alkene. So the biggest takeaways from these two examples is really watch out for the reading comprehension within the molecule. If there's a positive charge on an OH or an amine looking thing, it's no longer going to be a pKa of 16 as per alcohol and amine as per 40. It's going to become a protonated alcohol of pKa -2, and here it's 10. So really watch out for that positive charge, and also the phenol here. Phenol is alcohol, but if you do see it attached to a benzene, it's going to not be 16, but it's going to be a pKa of 10. Okay, so that's how you would attack those questions with comparing pKa's. There are other ways to compare acid strengths, and it depends on the type of question they give you. Another way, depending on the question, once again, is looking at the inductive effect. So they give you a couple of draw molecules. The molecule with the strongest electronegative atom, such as fluorine, is going to be the stronger acid. And the closer that electronegative halogen is to the H-bearing group, the more acidic. Now, the inductive effect is the ability for an electronegative atom to pull electron density towards itself, which makes that end more negative and the end with the hydrogen more positive, therefore being less tightly attached to the entire molecule, making the hydrogen more easily ionized, more easily lost, therefore a stronger acid. Now finally, the third way to compare acid strength is based on the periodic table position. If you are comparing across a period, you will have stronger electronegative atoms that will give you a stronger acid for the inductive effect reasons. But if you compare molecules that are down column, you will have a stronger acid, because the distance between the two molecules are going to be farther due to when you go down the periodic table, the larger atoms you have, so the weaker the nuclear attraction, therefore H is more easily lost. Now the second part of acid bases in organic chemistry is comparing which reaction is going to be favorable and which is not going to be favorable. There are two ways to do this, and the way you use depends on the type of question they give you. The first is based on an acid-base table. The strong acid will be on the top left, and the strong base will be on the bottom right. If the acid at hand in the reactants is on top of the table, which means it has a smaller pKa, and the base involved is beneath the acid, which means it has a larger pKa, then this is a favorable reaction. However, if your base at hand is higher in position than the acid at hand, which means the base in fact has a lower pKa, that means this will not be a favorable reaction. Let's try this. Question 94. I'll show you how I would go about this. So I make a table of acids and bases and my questions. So first, this looks like it gained an H, so this must have been the base, and it is an alkane, so it has a pKa of 55. Here it lost an H, so it donated an H, it's acid, and here there's an amine, 40. However, in condensed formulas, they don't show you whether this N is protonated or not, so you can either visualize it or draw it out. If it is protonated, it would not be an amine with a pKa of 40, it would be protonated amine with a pKa of 10. But in this case, it looks like it is not protonated, so we're good. So we're going to complete this table, and then we'll do some comparisons. Here, this lost an H, that's an acid, alkyne, 25. This gain an H, alcohol, 16. Alkyne, gain an H, the base, 25. Water, lost an H, the acid, 16. OH, lost an H, it's an acid, 16, because it's an alcohol. Here, it's an amine, make sure it's not a protonated amine. It's an amine, 40. And lastly, E, carboxylic acid, and the alcohol that gained an H. So with this table, what we do now is we compare based on this principle. In order for it to be favorable, the A is going to have a smaller pKa than the B, but the question is asking which one would not take place as written. So we're looking for a base that has a smaller number than the acid. Base with a smaller number than the acid. And that is the right answer. So 95, same way to go about this question. Now, that is the first way you can do this. The other way to do this, based on the type of question they give you, is the idea that the direction of the reaction will proceed from a strong acid to the weak acid. So from a low pKa to a high pKa, because high pKa's are more stable. So you would write out the entire reaction. You would compare the acid you started with and the conjugate acid at the end. Compare their pKa's. In order for it to be favorable, the initial acid needs to have a lower pKa and to end up with a higher pKa for its conjugate acid. An example of how that might look like in the question, they would ask, would this reaction be favorable in the forward direction? And this is very common with amines and protonated amines, because they want to test you on this particular principle. Amines have a pKa of 40. If they react something to form a protonated amine, it usually doesn't happen like that, because a protonated amine has a smaller pKa, so it's actually going to favor the reverse direction. So the next time you see a problem like this, first check if it's protonated or not protonated. And then if it's not protonated, and it's going towards the direction of being protonated, you know it's actually going to favor the direction that starts with the protonated amine. So I hope this video was helpful.